categories. As you can see in the for the straight through cable, we can use 8 pins with both sides using the 568A or 568B, as I mentioned before. And for crossover cable, again, as you can see here, we are crossing the pin 4 to pin 7 and pin 5 to pin 8 in both sides, 4 to 7 and 5 to 8. Again, here we are using all of the pins for the send and for example, crossing, and also this is another cross. But let me to say that in these categories, we have some advanced technologies that we can use that advanced technology for sending and receiving on different interfaces. And this is this concept is beyond the scopes of this course. Because of that, if you want to learn more than this about the color of the cables, you need to study in another courses. Okay, until now we learned about how we can connect two devices in one LAN, in Ethernet LAN, to each other. In some cases, maybe you need to use the for example, the straight through cable, and in another cases maybe you need to use the crossover cable. Don't forget, you should know the colors, the order of the colors. But in most cases, in practical environment, you don't need to every for example time check the colors. Only you can say, please give me one straight cable, please give me one cross cable. Because of that, in most cases we don't know about the detail of these for example colors. But for you as a master, as a network engineer, great network engineer, and as a person that you want to be for example to pass the CCNA, it's necessary to learning about these colors and use the correct cables. But let me to give you one important notation about the crossover cable and also the, for example, straight through cable. Look at this picture. In this picture we have two switches, for example switch A and switch B, and you know that we need to connect the TX interface of the switch A to the RX interface of the switch B, and also TX interface of the switch B to the RX interface of the switch A. You know it. Okay, this is only one example for understanding one important thing in the for example Cisco switch. Look at here, you know that we need for connectivity, for sending traffic, we need to connect the TX interface of this switch, okay, to the RX interface of the switch B. Let me to show you this with another color, for example look at here, now we have connectivity between the switch A and switch B, and we can send traffic from the switch A to the switch B. And after that we need to connect the RX to the TX, RX of the switch A to the TX of switch B. Okay, this is a normal behavior and this is a correct behavior. But assume that instead of the crossover cable, now we are using one straight through cable. Assume that I am going to connect these two switches together with a straight through cable. This means that we are connecting the two TX pin to each other and also two RX pin to each other. What is the result? You know that normally when the switch A needs to send traffic to the switch B, it should use the first pin, and then this traffic when is receiving in the switch B should drop this traffic on when for example the switch B is sending the traffic to the switch A should not accept it. Why? Because the switch B should send from this pin, and again in switch A we don't have receiver. This means that in normal behavior the communication does not occur, you know it. Okay, but we have one important feature. This is beyond of our course, but let me to talk about that. But because maybe you encounter with this feature, we call it auto MDIX. Okay, auto MDIX. This is the Cisco proprietary feature, or medium dependent. Okay, medium dependent interface crossover. What is the medium dependent interface crossover? This is a feature. We have this feature on most switches, on most Cisco switches, and maybe some another products of the Cisco. And the function of this feature is helping to the administrator. For example, when you are using the straight through cable for connecting two switches to each other, the switch B can understand that the TX interface of this switch now is connecting to the TX interface of switch of A. Because of that, automatically the switch B, okay, changed its pinout. And this means that the switch B can understand that we are using a straight through cable, or it can understand that the TX interface connected to the TX of the other device. Because of that, internally, okay, can change the pins, and finally we have the correct pinout with a straight through cable. You know that here we didn't change the cable from straight to cross, but the switch changed the pinout. This is the feature we call it auto MDIX. Because of that, in practical world, in the real world, when you are connecting two Cisco switches to each other with one straight through cable, maybe the connection work, okay, but this is not correct in our class. In our class or in CCNA exam, you need to use the correct cables, the crossover cable for connecting to switch or to same device to each other, or same type device to each other, and the straight through cable when you are connecting different type of device to each other. This is so important. This is only for informing about this feature, and this is beyond the scope of the CCNA class. The next thing that I'm going to talk about, that is the why we need to use, for example, two pin as such as TX plus, TX negative, and RX plus and RX negative. This is really relevant to the electricity and electronics. Because of that, let me to only give you a brief explanation about this. Look at here. When you have for example one node 1, okay, and this is the first device, and also we have another node 2 or device 2, okay. In node 1 we have one interface for one pin for send. For example, this is the TX send, okay, but and you know that the TX send, the TX should connect to the RX of the node 2 for sending the traffic, but actually we need a closed circuit, okay. Because of that, we need to use two pin for send and receive. This means that we need TX plus and RX plus, okay. Then the for example RX negative, let me to write here TX negative and also RX negative, okay. This is the RX negative, and after that we have a closed circuit. This is a closed circuit, and our current can be for example go from these links. Look at here. This is the closed circuit, electrical closed circuit. As you can see, transmitter with two pin TX plus and TX negative can connect to the receiver with two pin RX plus and RX negative. Because of that, for sending, for example, traffic from node 1 to node 2, we need two pin for send in node 1 and two pin in the node 2 for receiving the traffic. This is another example when we are connecting a PC to a switch. Look at here, PC is using the pin 1 and 2 for send for transmit traffic, and pin 3 and 6 for receive of the traffic. Because of that, as you can see, we are using two pin for send, pin 1 and 2 for send, and pin 3 and 6 for receive. Here in the switch we have the reverse scenario. Pin 1 and 2 is using for the receive, and pin 3 and 6 are using for the transmit. As you can see here, again we have one closed circuit. Data flow can be forwarded from transmitter 1 to transmit to receiver, and then here we have opposite direction for transmitting the data or data flow from the switch to PC. And finally, when we are using 4 pairs or 8 wires for send and receive, we have these circuits, and this is the circuits between the PC and switch, and this is a straight through cable. Let me to write here. Now we are connecting the pin 1 to 1, okay, and then 2 to 2, and then 3 to 3, 4 to 4, 5 to 5, then 6 to 6, 7 to 7, and 8 to 8. This is a straight through cable, and you know that when we are connecting switch to switch, or for example PC to PC, we need the crossover cable. Alright, in this video we learn about the Ethernet LAN, some of the fundamentals of the Ethernet LANs. For example, we learned about the media we are using in the physical layer, and you know that the Ethernet has two parts. The first part is about the physical layer of TCP/IP, and the second is about the data link layer of the TCP/IP. In this video we learn about different categories of the twisted pair cables, and also the differences between the, for example, twisted pair cable, about the insulation, about the speed, and some other things. Also, finally, we learn about the different connections that we can create with one twisted pair cable, for example, straight through cable or crossover cable. In which scenario we are using a straight through, in which scenario we are using the crossover cable, and some other terminology and things about the Ethernet LANs. In the next video, again, I'm going to talk about other features of the Ethernet LAN. For example, we will talk about the fiber optic. You know that here we used only the twisted pair, but we can use the fiber optic for transmitting the traffic of the Ethernet, the frames of the Ethernet. In the next video, we will talk about that and also some other topics about the Ethernet LAN. Now it's a good time for reviewing all of the topics, all of the concepts that I mentioned in this video. After that, please come with me to the next video. Again, we will talk about the Ethernet LANs, and we will be a master in CCNA, in network engineering, if we learn all of the steps carefully and with maximum quality.